Thank you everyone for joining and welcome to the session of Mastering Modern Software Distribution. My name is Philip. I'm one of the co-founders of Glasscube, and I'm originally from Vienna, Austria. I always like to start the session with giving a little bit of background about myself, like about the speaker, so you might relate to some of my hobbies, hopefully. Studied computer science in Vienna University of Technology. And after that, I was the CTO of an alerting company where we built an alerting system for firefighters in Austria and Germany. So we really spent a lot of time creating on-prem software and infrastructure that really executes and runs in the alerting centrals and dealing with all kind of data and on-premise stuff. And I was always super interested in open source software. We utilized also Kubernetes quite a lot. So back in 2023, my co-founder and I started a company called Glasscube, where we specialize on open source development and general Kubernetes management and managed services. Our startup got accepted into the Y Combinator batch last summer. So we spent last summer in San Francisco and diving deep into the ecosystem there and continuing developing open source software. But on today's topic, we're gonna take a look on what it actually takes to not only providing SaaS, right? So on-prem or distributed software to customer managed infrastructure always means that you're not able to just host and manage the software by yourself, but you need to kind of ship your software to your customer premises. Means you're developing cloud software by yourself, but it will be then executed in your customer premises, so multiple times. So this is quite different from just maintaining your ordinary SaaS software. And customers' expectation, although they still run everything by themselves because they expect data sovereignty and control about everything. They don't even want to share their data with you, even if you are the software vendor and probably the domain expert. They still want to have complete autonomy about their update and management process, but they're often really not able to do everything by themselves, so they still want to have some kind of support from the vendor. So if we speak to a lot of customers or speak to a lot of friends, especially if the company is a younger company, the first thing that comes to their mind is perfect, Silicon Valley startup show, Pied Piper. Some of you guys know it, think inside a box, put everything into a box, ship it to the customer and fire and forget, and it will run forever and good. But the reality is that doesn't work. It's if you send the hardware once and then you need to come back in a couple of weeks or months and put a USB stick in and do some updates, this doesn't scale. And there are much more better ways in software delivery. Another common way of people distributing software via zip file was actually this is a super close to a real-world example of a friend of mine who asked me, hey, Philip, how should I do software distribution? Because currently they just zip everything up, the Docker Compose with all the source codes and everything, to build it locally. And the client just needs to unzip it, make the Docker Compose build, Docker Compose up, and that's it. But as soon as they send them the new zip version, the process is not reproducible because in the second time they could not start the stuff because the Docker images or the Docker containers were already running with the same name. So we're gonna take a look on what it takes to actually do it meaningful and in a long-lasting way. Most of the super important stuff, if you really deploy to your customer managed infrastructure, is are you using any third-party dependencies, right? So if you're using a web authentication, a managed web authentication like Auth0, you won't be able to deploy this into your customer premises. One of the second things we always look if you want to deploy to on-premise customers is how do your commit messages look like? Because we're going to see later in examples that you can really create beautiful release notes based on your commit messages. And how do you perform secure releases? How do you make sure that your image is not altered between it's built in your GitHub Actions pipeline until it receives your customer. So we take a look on how to sign the image, how to create an SBOM, attach it to the image layer, and all this fancy stuff to really make sure that the software that you ship to your customers is still authentic. And then obviously, or not obviously, like we look at the versioning scheme, and we all know like semantic versioning. That means your version is should not be just a number if you increase it. I mean, it's fine if it's your internal SaaS application and nobody else needs to rely on your versions. But usually, like in the open source software world, or in general in the software world where they are like distributed, companies try to follow the semantic versioning, meaning like it's 3 digits separated by dots. The first number is obviously a major version, so you increase the major version, not if you launch like a fancy new product feature and your marketing wants you to increase a new version, but you actually, if you do it, if you have a breaking change. That means you increase it if your clients or if like the customer that runs the software needs to do some manual tasks that like really are major breaking changes. Also like if you're any backwards compatible changes. So if you upgrade it to this version and you shouldn't like roll back to a previous version. Minor features usually introduce new features, but they don't break the API. And patch versions have like no functionality change at all. They're just fixing bugs or any regression that occurred in the last minor or major release. So let's take a look at the commit history. And I think most of us know the pattern of conventional commits. It was, I think, firstly like mostly used by the Angular team. I think they made it big, is where you also have like a prefix and then a scope of your commit, and then you have your actual commit message, meaning it's a chore commit if it's like a miscellaneous commit that has nothing special about it, but there was like fix commits where you like fix an existing behavior, or like a feature commit, which we see down there, and the feature commit is introducing a new feature. And if you are able to follow the conventional commit rules, you can easily create a nice release lock and even automatic versioning, which you're gonna see in a second. But obviously, like our pull requests escalate quite a lot, right? We have back and forth and feedback, and then there are some merge commits, and you probably won't be able to read it, but you see it's a whole list of like reviews and smaller commits. And the best way in order to keep a clean commit history in main is really always make squash commits. And this is something which I think the Renovate team has a really good developer contributions guideline on how to really have a clean commit history. And this is also the way how we enforce it, or like what's actually best practice from our view is like to have like semantic, like a conventional commit message at the pull request title, and also have this enforced actually by a GitHub action that runs on every pull request sync or update stuff. And then you can have like really funky commit messages inside your branch, inside your pull request, and as soon as you merge a feature and it's ready, everything gets squashed to one commit, and the pull request title will become the commit history. And then what happens next? We can take a look at a tool called Release Please. Release Please is a tool created, I think it's close to the Google ecosystem, and it will run on every commit on main, and it will create, or it will like create and maintain a branch to your main to create the next version of your software. And it automatically detects the conventional commit messages type, and it sees if they're only like fix commits or chore commits, it will only create a bug release. But as soon as commit message is in main, which has the feature prefix, the next version of the release of the branch will change from a bug fix release to actually minor release. And you can actually also use commit messages which have no diffs, but just like plain commit message commits to give release please some additional hints on now, please create a minor release, please the next release version should be this and this, and you can just like create message commits. And yeah, but I mean, if we create the release, we cannot do everything automatically, right? Because obviously if we create a release, we always need to update some version in the package.json file or in any other file in the documentation, yada, 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 yada. But actually, Release Bliss also has a solution for this. So Release Bliss has let's see. Release Bliss has a config file, which is called the Release Bliss config, which is actually able to not only create a new pull request on your main, but also do some automatic updates of versioning. So you can give him a list of files where it will automatically detect which version of your source code you should update. For example, if you have a package.json file and you want to release the new version, and Release Bliss in the release branch will automatically see, okay, current release version is 1.7. In this diff or in my pull request to main, as soon as the branch will be merged, it will also like pull up the version of the package.json to 1.7.1. And you can create really an arbitrary list of files which Release Bliss should look at, and should also make sure that everything, everywhere your software version is mentioned, it's updated by Release Bliss inside the GitHub action. And this is now a diff view about the Release Bliss branch. And as you can see previously, our Helm chart, for example, or the Docker Compose file was using 1.0.1 of the distro software. But in this branch, maintained and updated by Release Bliss, it will automatically bump all the version to 1.7.1. So as soon as this version, as this pull request is merged, all the new versions are updated, and Release Bliss also automatically then creates a tag on main, and all the build stuff is executed. Exactly. This exactly happens when you introduce Release Bliss and merge the pull request. It will also create a GitHub release with really beautiful release notes, and yeah, then you have really a tag, and you have like really good semantic versioning, and have really made a good release. But I was mentioning before, we also need to make sure it's secure. So how we can make sure that the release is actually secure and cannot be altered. Most of our software nowadays is like distributed in OCI images in Docker image, and there's like, if you really want to create like good and like production grade Docker images, there are three things from our opinions that you need to consider. First thing is like obviously SBOMs, like a software bill of material. It's like similar to your shopping cart, or like the ingredients you use to build up your software. You can put a shopping list inside the Docker image, and then everyone sees, okay, this version of your software uses following ingredients, following packages, following dependencies, and they can then use some security scanners and feed the SBOM into it, and then they will see, okay, which version might be vulnerable, or which version is not allowed by our company standards. But how can I attach actually the SBOM to an image? And then how can we sign everything? So we can make sure, okay, these are my image layers, these are my SBOMs layers, and how we can make a cryptographic signature that the like the consumer or the customer of your software can verify that everything is in there. Yes, and I think creating SBOMs, first when we looked at the topic, we thought, wow, it's super complicated and it's super hard to do. But actually, it's only like 2 steps in your GitHub action. There's like for Anchor, it's a company that produces or like maintains an open source library called Sift, and they have created a GitHub action where you just need to feed in like a package log file, and from the package log file they can create an output file which is in the SPDX format, and they will like put the SPDX format in the dist like frontend SPDX JSON folder, and then the Docker guys also have a library, or like have a function, a parameter, just to use the SBOM. And then if you build like a Docker image with the Docker with the Docker CLI, it will also automatically create the SPDX files for all your like system packages that are used inside the Docker image. And it's pretty funky, but the Docker build-x actually looks at the folder, which is like, I think, varlib SPDX or something, and like looks for all the SPDX files and then merge it automatically and will put it automatically in one layer of your Docker image. So this is literally everything you have to do to just create an SBOM file and put it inside your container image. Yes, and how can we get it out of the Docker image? Like the Docker build-x image tools has a subcommand where you can just put a container image. In our case, it's a develop image and a char, but you can also use a tag, and then you can inspect, and then you can format, okay, I want to have the SBOM for the Linux AMD 64 architecture, and from the SPDX format, and if you like execute this, you will receive a list of all the dependencies of your Docker image. And then the SPDX.dev is a project from the Linux Foundation. You can upload the SPDX files, and you can also validate that the SPDX files are actually valid. And yeah, it's like an open standard which is maintained by the Linux foundations, and private companies build like tooling around it, like Swift or like the Anchor guys did. So the next thing is we have a Docker image, we have a SBOM in it, but how can we sign it? And the most common tool used for signing OCI images is cosign. And also the guys at Sigstore have like the cosign installer GitHub action created, which authenticates. And this is a little tricky because if your image is built inside the GitHub action, who is actually the guy or the person signing the image? Because it's an automatic workflow, and so it's actually like the job of GitHub to provide the identification or the authentication for signing the image, and also like validating the image. And if you build your image inside GitHub Actions, you sign the images actually with the OIDC token of the GitHub action itself. So once you installed cosign in your GitHub Actions runner, you can execute the cosign CLI and sign it with the digests you got from a previous step, like the Docker digest and the tags. So then you're gonna sign all the tags and all the images with cosign and using the GitHub OIDC token. And the question is now, how can somebody actually verify that it was like authentically built with the GitHub action and also the right GitHub actions run? Because like if you alter an image and you rebuild it with GitHub, you might be able to spoof the identity. But the way it works is inside your OCI registry, you not only have the normal chars of your Docker image, but cosign will also push another char, like another image inside the container registry with the SIG, like with the signature of the previous image. So you have not only the image, but also the signature of the image inside your container registry. And you can then use cosign again to verify that a specific version is related to the signature provided. Because the signature, because we'll always look like for the image, and the same image.sig will be looked at, and we can see the certificate issue are like the tokens actions.github user content. So these are like all the tokens of the GitHub actions can be passed there, and the certificate identity is actually the exact workflow run that created the tag 112.5. So in this way, like GitHub provides you a list of tokens, and the exact identity is like this workflow build. So everyone that like verifies your image can make sure, okay, this image was really created by GitHub, the GitHub organization Glasscube, and the open source project Dister in this workflow, and it was not altered. The third step that is super important if you want to distribute your software to your target customers is multi-architecture images. Because we all know it, some people run on Windows, some people run on Linux, some people actually run on Mac, on ARM Linux, yada, yada, yada. So you cannot simply build your AMD 64 image and hope that every of your customers is able to execute it and build it fairly well. And this was actually something we didn't look into for a very long time. And what you can do is you can do with like Docker buildx, you can specify multiple architectures. So you can use like your AMD 64 machine to also cross-compile for an ARM image. But this is actually super, super slow. And we did this for, I don't know, half a year. And always our GitHub actions like timed out. It took like 20 plus minutes to do the cross-compilation because our software is written in Go and has a dependency on Kubernetes and Helm, so it like compiled everything and cross-compiled everything. And then I think exactly last week we introduced like native GitHub action runners. So we are not like cross-compiling on AMD and ARM, but we actually have like specific runners that are on the ARM architecture and some on the AMD architecture, and we let every runner build the image for the target architecture and then push like the ARM image and push the AMD image to the container registry. And then we have a last step of the workflow where all the images are built for both architectures. And with the Docker, build tool, they are combined again to one image, one multi-arch image, and then pushed again to the registry. And we actually saw a performance increase from 20 plus minutes to 5 minutes. So it was really like slashing down 15 minutes of every CI/CD build. So if you're doing some multi-architecture images, please really look at GitHub Native Runner. You can do metrics builds, and we can look at the pull request later on. It's also open source, and if you're in this if you like need to tackle these kinds of problems, really think about native like compilation and not any cross compilations. Perfect. We now got a release. We got a secure release, and how do we send it over to our customers, and what are like the different deployment models our customers can have? We all know the deployment model on the left. It's self-service SaaS, is where you as a software vendor are also operating the infrastructure and are in full control. So you know exactly for which target architecture you build it. You might not even need to sign the images because you are a closed loop and you can trust your containers and so on and so on. But if you're looking at the self-managed case or like the bring your own cloud case, the deployment targets can be diverse. It can be some cloud hyperscaler from AWS to Exascale to yada, yada, yada. It can really be an on-premise data center with Linux or Windows servers or some hybrid cloud environments. And there's always like this kind of metrics, because if it's self-managed on-prem, even air-gapped, you as a software vendor have basically zero to no control about anything. And if you're SaaS, you have like full control. And then they bring your own cloud, and self-managed cloud deployment models are somewhere in between. The bring your own cloud model is a model that emerges more and more, where like a software consumer says, yeah, I want to have it inside my domain, inside my cloud account. I want to see where the data is. I want to be able to pull the plug, but I don't want to do any operational task. I give you like, I create a sub-organization in my AWS, so I create a own subscription in my Azure and give you full access to the AWS or Azure account, and you can manage everything. This is also easy for the vendor because it can exactly spin up the machine and manage everything he needs. Or like the Self-managed on cloud is a little tricky because it's still owned and operated by the vendor, but by the customer, but the vendor gets some kind of shared responsibility or can log in from time to time and manage what's there. And what we're actually seeing is like huge companies are offering always more and more bring your own cloud scenarios. For example, Databricks, or like other big companies offer this because it also has a benefit on costs. Because if you're like a huge software company, you might have already some pre-arranged or like prepaid cloud bills. So you're also incentivized to run more and more software in your own cloud on your own AWS bill. And you don't have the vendor doesn't need to pay the bill. So yeah. And what's like between you, a vendor, and your customer is obviously always a container registry. The best way to distribute like the software artifacts is a container registry. And nowadays with OCI registries, you can actually push multiple types of artifacts. You can push Docker images, you can push Helm charts as OCI images, you actually even can push Terraform modules. So there's no need of like sending zip files or any other stuff. You can just use a container registry. There are multiple out there, and give the customer access to the container registry. You can often like specify which specific tags of an image or an OCI image a customer is able to access, and then the customer can download it. The second super important thing if you're dealing with containers, please always use like minimal base images. For example, if you're using Go, you can use Go really distroless. Just bump your binary in there and you have a super small OCI image. And what I said before, attach or like also push the signatures and attach the SBOMs inside your Docker container. Then you want to restrict tags to your users. So if your software is not open source and can be downloaded by everyone, you really want to make sure that if you have a specific bug fix release or like a branch for a specific client, you're not sharing this branch with any other users. And what's also important if you're thinking about container registries is a download history, especially in some air-gapped or customer-controlled environments. You often don't know which version of your software your customer is actually running. So if you're looking at the download history, you can assume if the image version 1.7 was downloaded, he probably runs 1.7. And this also increases your support time. One of the container registries you could use is Distro. This is an open source software developed actually by us, by Glasscube. It's completely open source, Apache 2 licensed. You can self-host it or use our SaaS version, but it actually features a download history where you can see exactly which customer downloaded which artifact at which date and from which IP address, so you can know, okay, my app demo customer is using the chart 2.8 with all the also like the CMS and the CMS app, so we know, okay, it actually downloaded the Helm chart, and the Helm chart actually also downloaded the GitHub images, more like the container images. And what you can do with like license, you can actually make sure that the specific customer only get access to artifacts for a given time, for a given tag, over a given duration. Perfect. This was the case for container registries. If your customer doesn't have, if your customer doesn't want to have access to the local like servers or anything else. Another thing is if your customer is less restrictive in what to do, you can also use deployment agents. Meaning, like deployment agents, we know it from data collection agents like the Datadog agent, the Dynatrace agent, which is installed in your Kubernetes cluster, but you can also use something like a deployment agent. It could be, in the simplest case, just Flux. You can just install Flux inside your customer's Kubernetes cluster, and it will automatically reconcile everything with your GitHub repository, or you can use like more sophisticated agents that are not only able to reconcile the application state in your customer target, but also monitor the infrastructure, monitor the application health, even perform updates, and are connected to a web portal where customer actually can press the buttons or press the updates themselves. And this actually provides agents for Terraform, Docker Compose, and Kubernetes. And you can even integrate everything into CI/CD. We'll take a look at the demo later on. But what about air-gapped systems? I think air-gapped systems are like the holy grail of deployment, because even the operator who needs to deploy into the air-gapped system is super, I don't know, nobody likes to deploy to air-gapped systems because you actually cannot like side load anything. And there's a great tool out there that's not from us, that's from a company that's called Defense Unicorns. They're doing a lot of contracts with the US government, and they developed an open source tool called zarf.dev, which I found really, really interesting. And zarf.dev is a CLI tool that is able to pull everything from the internet and then push it into your air-gapped system. That means you as an operator need to have access to the internet and to the air-gapped system. And then with Zarf, you can, for example, input or like feed the Helm chart, and then push it into your target Kubernetes cluster. And the way it works is like Zarf is a huge binary that has a lot of like third parties already built in. And if you bootstrap Zarf in an air-gapped Kubernetes cluster, you will automatically get a Git server and a container registry and a lot of custom resources for your Kubernetes cluster, custom resource definitions. And as soon as you create take a package from the outside, you'll package it with Zarf, create a custom resource, fetch all the OCA images that are part of the Helm chart or the Docker Compose, yada, 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 and it will push it into the air-gapped Kubernetes cluster, into the container registry, and then you are able to deploy Zarf packages, and Zarf will ensure that everything that's inside the Zarf package was already pre-fetched and pre-rendered or like pre-pushed to the target Kubernetes cluster. Perfect. Then I think we still have a couple of minutes left to look at the demo of Distro and see how it's possible to easily invite a customer to your software application and distribute the software with an open source tool. For this, I will switch to screen sharing. To screen duplication, yes. Demo time, perfect. So what we are seeing here is like the vendor platform, or like, let's start it the other way around. Like this, there is an open source software, Apache 2 license, everyone can use to distribute software. And what you see if you have like multiple deployment targets, as a software vendor, you easily see all your deployment targets with their memory usage and CPU usage of all your customers. These, for example, are your clients where you install the agents, and some of your customers, like an air-gapped factory, they're only pulling images from your container registry. And the first thing, if we want to invite a new customer, we can invite the customer and call it like the DevBcn admin. Let's call it DevBcn at, I don't know, distro.com or distro.sh. And actually it's super nice. There's a software called MailPit, which is a local SMTP server, which you can run inside a Docker image, and it will intercept all your mail. And you can configure like the local SMTP server, and you get a user interface, and every mail you send, you don't actually have to send it via a real SMTP server, but you can use it via MailPit, and then you receive all the mails. Perfect. I'm gonna copy the link, because now perfect. And now created my password. I'm still in Bratislava, but I can't see any deployment or artifact yet. But first, I think we want to make sure that we are not in Bratislava. But we can change this later. We can say, okay, we're not in Bratislava. We're actually at the DevBcn. Welcome to Barcelona. And now our customer sees they are in the Barcelona portal. and they have no deployment, and they cannot see any images, because the first thing we need to do is give them a license, and we call it the DevBcn license, no expiration date, and we give them the Nginx with all tags, for example, and we give them the hello world, and what else should we give them? Yeah, I think that's fine. And we give it to the DevBcn, and hello world, Nginx, let's give it a chart, let's give it ClassCube. Perfect, and I think now we're able to see this, let's go in the light mode here. We see these images, and now if we're a customer, we can pull a specific image. We just need to log in with the container registry, and then we can actually do this. We can create a personal access token. Perfect, expires in 1 month, that's fine. And then we can, let's copy this. We can log in into your container registry. No, I didn't save the token. So we can now log into the container registry. Perfect, we're logged in, and we can now pull an image. Let's pull the hello world image. I don't know what happens with my copy to clipboard. Perfect, we pulled the hello world image, and we now see as a software vendor in the download history that DevBcn just downloaded the hello world image, so we can assume hello world is running there. I think the next thing we want to do is we want to look at an application, and let's look at the pod info application. It uses the pod info OCI chart, and we can give a license to the DevBcn customer with also no expiration date, and we give the pod info to the DevBcn, and we don't need any private registry, and we can now create the new deployment from the type Kubernetes. We call it DevBcn in the DevBcn namespace, enable cluster scope permissions, and we just need to target all. Perfect. We are in a Kubernetes cluster. We can create a new create ns DevBcn. We created the DevBcn namespace, and we can now deploy to the DevBcn namespace. And we want to deploy the, let's see, the error image, right? With no image, and we want to enable log collection. Perfect, it's running, but we get an error. Let's inspect it. Helm install failed to fail, improper constraint. And I think this is super important if you want to deploy something and you can immediately see an error. Not only the customer sees an error, but also you as the vendor see, okay, let's see where it is. My DevBcn deployment actually has an error. And this is on purpose because we have the error version, and now we can switch to any other version and deploy this one. And we'll see that it's now running, the agent is running, and we're actually now creating a DevBcn pod info container, which is running, and we see everything now switches to green. We see now the logs are good, the logs are green, and we have like not full visibility, but we have some kind of visibility into my customer deployed environment. So yeah, with that, I think I still have some options. We still have around 10 minutes left. We can either do a Q&A session, or we can show you like what you can do with the distr MCP server to let an AI try to figure out and debug this kind of stuff. I tried to prepare some AI demos, but the AI demos always have been that flaky because the LLMs always provided some kind of different outputs, and the MCP servers didn't do exactly what I wanted. But it's up to you. You can see me. You can either have like 10 minutes Q&A, or can see me like 10 minutes suffering with trying to let an AI update some deployments. It's up to you. Maybe we will first start with Q&A. And depending on how many questions we have, I can show how to do this with an MCP server and an LLM to see it in like practice. Are there any questions? I can also raise a hand of who wants to see the MCP server and everything. Okay, so we're gonna take a look at the MCP server. I don't know who also have been in the previous talk from the colleague who presented the MCP server, but an MCP server in general is like a model context protocol server which exposes specific APIs to LLMs. So LLMs can interact with your API. The best tool to inspect or to work with an MCP server is the MCP inspector, and it's an NPX tool which you can run. It's like NPX, like Node Package Manager remote executions, directly runs the MCP inspector, and you get a web interface. I'll make it a little bigger, where you can inspect an MCP server. An MCP server can have like 3 different protocols. So server-side events, streamable HTTP, and standard in, standard out. If you're using a local MCP server, it's just like executed locally. It mostly uses standard in and standard out. But remote MCP servers used to use server-side events, but this got deprecated in favor of streamable HTTP. Although this MCP server was created like a month ago, where server-side events still have been the go-to way. And let's get the MCP server running. Exactly, we're gonna use the distro server, which is like built in dist, and we have now our distro server running, and we provided our distro token and the distro host, and we have now a streamable HTTP server running. And now with the model context inspector, we should be able to connect to our local running MCP server, and let's see if it works. Error, did you have correct? We don't need any authentication, we need authorization, but it's not on, it's on this part, right? Let's debug it. Base URL in server-side mode. It should be MCP main go. No, it should be port DB localhost SSE. Right, does not work. We'll get it to work, I'm sure. Started to surf in SSE mode. We can try to rebuild it. So, this is, we need to, let's see if we can Getting it. Do you access session token? Yes, this is my session token. And we need to configure it. We need to add the session token. How can we add the session? Like the MCP inspector always changes. And we need to add a session token, but how can we add a session token? Let's see, localhost, if you have something in the MCP auth token. Let's copy this from here. Copy it here. We have now, hopefully, yes, now we're connected. You see, in the MCP world, everything changes all the time. And previously, the MCP inspector executed with the session token directly in the as a get parameter, but this changed somehow, and now you need to look at the request history and manually add the session token over there. But now we're connected to the SMP server, and we can browse what kind of tools are available for the MCP server. Like an MCP server exposes a list of tools, and we can look at it. And for example, in the distro world, we have like multiple tools. You can create the user, we can delete an application, we can delete the file, we can delete the user, we can get an application, we can get applications, and we can now, let's see, we have a list applications, and we can execute the list applications. And the list applications then returns a JSON for all my applications. And this is just a tool to test the MCP server, so we know the MCP server is working. But the real power of MCP servers actually comes there when we can put this input into an LLM. And for this, let's see if this works, we can use, for example, GitHub Copilot in the agent mode and configure specific MCP servers. And we can use the Kubernetes MCP server, but in our case, we're using the distro MCP server. Which is configured in a file called mcp.json, where we have configured the distro MCP server exactly with a distro host and a distro token. And we can now ask the LLM, show me all the distro deployments. And what hopefully happens, what happens now is the LLM understands, okay, it got the whole context of all the MCP tools, send it to the LLM, and the LLM answered, okay, what you might do is you want to call the list deployment target endpoint from the MCP tool with following request body. It's empty, but you can execute this, and you now, your MCP client sent an HTTP request, which we saw before with the model context protocol inspector to the MCP server. The MCP server then sent an REST HTTP request to the distro API, returning it to the MCP server, and the LLM then interpreted all the JSON and gave us a good list. And now it found all the distro deployments. Okay, show me all distro deployments that are not running. Let's see if it's that smart. Wow, and it directly got, okay, there are like 2 deployments that are not running. Perfect. Show me the logs of these deployments. I don't know if this works. It will call the get the deployment logs endpoint with a specific ID and limit 20, and we continue. It actually understood there are 2 deployments that are failing, and it will now try to get the logs. Let's see if this works. Yeah, and this is like the limitation of MCP servers and LLMs. They are always like the first couple of requests really, really work. But if you then want to go deeper and fetch the logs and analyze the logs, in all my like preparations and demos, we see that the MCP servers and the LLMs together kind of work, but they break at some time, or it's a limitation of the client, like IntelliJ with the MCP client I'm using. This is like This is why I said you will see me struggle 10 minutes, because some kind of requests will always time out, or something in the MCP protocol or in the tools will change, and you need to manually adapt and fix a token. So yeah, this is everything sadly I could show you with the MCP servers. But if you have any questions regarding MCP servers, deployments, or air-gapped systems, feel free to, yeah, it's now time for questions, I think. Thank you.